Hi, good morning. And in this video, I'm actually going to do the analysis of palm oil. What it is, we've had an inquiry. It's quite a serious, let's say, problem that they're trying to solve. I'll discuss that problem very quickly and also discuss how the technology stack can help them. So don't think that this is going to be all talk. In fact, I'll go back to the slides now. So I'll be using that hardware very shortly. So I'm talking about palm oil and Sudan Red adulteration. The overview on this is that there's a synthetic group of dyes out there called Sudan Reds. These are kind of azo dyes. It just means if you're a chemist, then there's this sort of double nitrogen here, and they have quite strong red colors, and people are using them to kind of adulterate things like chili powders and palm oil so that it appears brighter red. In particular, African nations, Ghana, for example, they do actually have there's a lot of adulteration going on, and there's a challenge when it's detecting it. And this is a lot of things that ZP gets involved with. The sort of challenge is that you can detect these kind of dyes, but it would be on something like an HPLC, a high pressure, they call them high-performance liquid chromatography these days, though historically the P meant pressure. But anyway, HPLC systems are quite sophisticated. You need a real lab. They're not portable. They're not suitable for deployment in the countries of origin on this. And even if you're using it as a sort of border control, it's an expensive piece of kit to own, etc. And you're talking about products that are kind of commoditized, so it's very hard to justify the costs. You have to justify the costs because of the toxicity, but it's hard when the material you're testing actually has a low value, and the way you're testing it actually is quite costly. So you do need a different type of technology for that, and I'll be using the SensiOil Potentiostat SensiOil platform this morning for just seeing if we can basically get electrochemical data out of palm oil. I'm not going to go on to do the Sudan Red because I'm waiting for it to arrive, but maybe if you watch some later videos from us, you'll actually find me doing Sudan Red as well. It's just to say that the EU is very aware of this, the European Union is very aware of this, the FDA is also very aware of this, and so that these kind of trading blocks are putting regulations and testing in place. But of course, it doesn't help the local markets, where in fact the local people again can't access HPLC, high performance liquid chromatography, and so we do need sort of lower cost platforms potentially to do that kind of local testing. As it is, I did buy some palm oil because I'm in a temperate zone. The palm oil is more like a sort of palm wax because it's got this kind of melting point that's probably somewhere around room temperature. So for me, it's quite waxy, but I have weighed some out. I have put it into a proprietary ZP buffer, and I am going to make a measurement now. So let me just go to here and talk you through the measurement. So I'm going to take one of our kind of ZP electrodes. I'm going to now I've got a couple of electrode types here. I think if you're doing academic R&D, it's sometimes easy to use our circular electrodes. I think that's called the 501. This is the hypervalue carbon electrode. So I'm going to use just the rectangular one because I'm kind of more familiar with it. But if I was doing an academic program, I'd probably be using these because they're easier to pipette onto, let's say. Anyway, with that said, let me grab a sample. Whoops a daisy. Let me grab a sample. Right, the nice thing about electrochemical techniques is you don't need much of a sample. Just 50 microliters is enough. Now this works using, whoops a daisy. This works using an app system. So we've got this app that's in Bluetooth connection with the instrument. I'm just going to give this a quick name. I go continue. The app is asking me what kind of dilution that I'm using. I used a 1 in 10 dilution, so that's fine. I'll make sure that I choose 1 in 10, which I'm doing, and then I'll go start measurement. And basically it's off now. So it's grabbing electrochemical data in real time, and then it will actually send it up to the cloud and I'll be able to look at it. So I'll let it run. So this is the SensiOil instrument using some of our ZP electrodes, and then it says basically says upload complete. So the upload is now complete. So I'm just going to quickly go to something called Julie. Let me just share my screen with you. So here's Julie. I'll just do a quick refresh on that. The data that I've just gathered should be up there. Yeah, there it goes. So I get a very distinct signal with palm oil, which I actually am able to assign. So I can see that very distinct signal, really beautiful signal actually. If you're an electrochemist, you think this is really something. So the quick answer to these people is, can the ZP technology be used with palm oil? The quick answer is actually you can, and actually you get really quite nice voltammetry, which is actually you can turn to your advantage. So in summary, palm oil is a staple or staple food commodity. It has been adulterated with things like Sudan Reds. The incumbent technology for detecting this kind of thing, let's say, and quantifying it is actually HPLC. It's not even applicable. It's applicable, but I wouldn't say it's even practical. In places like the US and Europe, you do need lower cost, simple to use instruments. So I put my hand on such an instrument here, and it was simple enough to prepare that sample, and actually you saw how quick the analysis can actually be. I did that analysis probably in about 15 seconds. If you do have any questions, don't hesitate to reach out to us. Okay, thanks very much.